What's going on, everybody? Welcome back. We have another rate of change question coming up, and this one's sort of unique. We haven't done a question like this. So basically, we're given a displacement versus time graph, and we have to answer these two questions. So we have to state the range for the displacement versus time graph, and then we have to draw a related speed versus time graph that corresponds to this graph here. So let's start with part A, state the range for the displacement time graph. Well, notice that the range for this graph is from 10 meters all the way to 3 meters. So that would be your range there. So the way we can write that is we can say y is an element of real numbers, or we can write displacement as an element of real numbers. I'm just going to write a y variable, and y has to be between 3 and 10. And inclusive of both 3 and 10. Because notice it hits a displacement of 10 meters and it also hits a displacement of 3 meters. So it has to be inclusive of those. That would be the range for this displacement versus time graph. Basically, what dependent variables or what y values is this graph hitting? And now moving on to part B, the toughest part of this question, we have to draw a speed versus time graph that relates to this displacement versus time graph. So I drew this preliminary graph here just to save time. So notice how the time on the x-axis is the same as the time here. And then the speed, I just picked some arbitrary numbers, so I went from 1 to 5. We can always change this if we have to, but let's keep that scale for now. So how are we going to do this? Well, the first thing to notice is that this displacement versus time graph, it's split up into 4 sections, 4 sort of shapes. We have this shape here, so we'll call this like section 1. Then we have this horizontal line, that can be section 2. We have this downward sloping line, which is section 3. And then we have another horizontal line here, which would be section 4. So our speed versus time graph, we're going to split up into 4 sections as well. So let's figure out what's happening in section 1 first. Notice that the displacement is changing at an increasing rate, right? So if you remember from the displacement versus time graph lecture videos, which I would highly recommend you watching if you haven't before going over this question, we said that when a displacement versus time graph takes this shape, then what's happening? Well, if we drew tangents, notice as time goes on, the tangents are getting more steep. Hence, the speed is increasing. So we know here the speed is increasing. Okay, and this first interval is happening for the first 2 seconds. So we know the first 2 seconds of our speed versus time graph, it's going to be increasing because the slopes of the tangents are getting more steep. Speed is increasing. Now, what is the average speed? I always like to figure out what the average speed is in an interval, even if the speed is increasing or it's decreasing, even if it's not constant. So notice how in the first interval, the object goes from a displacement of 10 meters to 6 meters, meaning it's traveled 4 meters in 2 seconds. So on average, the object's speed is 2 meters per second over that 2-second interval. Now, because the speed is increasing, that means that in the first half of that 2-second interval, the speeds are going to be less than 2 meters per second, and then in the second half of that 2-second interval, the speeds are going to be greater than 2 meters per second. And then if you average all of them out, they'll average to 2. So what I like to do is I like to take this average speed and I like to put it in the middle of the interval. So the middle of this interval, of this 2-second interval, would be at 1 second. So at 1 second, it's safe to assume that the object is traveling at its average speed for that interval of 2 meters per second. Okay, so because the speed is increasing, all of the first half of that interval is going to be speeds less than 2 meters per second. and then all of the speeds in the second half of the interval are going to be greater than 2 meters per second. Since 2 meters per second is sort of like the middle, then we can assume that the object is going to hit a speed of 4 meters per second at that 2-second mark. Meaning at this mark here, at the 2-second mark, if we draw a tangent, then hopefully it has a slope of about negative 4 meters per second. However, because we're dealing with speed, if you remember, we always look at the absolute value. This is the velocity, so the speed would be positive 4 meters per second at that 2-second mark. So I feel like this is a good assumption here. Notice how the speed is always increasing as it's shown in the graph. Now we don't know whether it's increasing at a constant rate or an increasing rate. You can't tell from a displacement versus time graph. So here we assume that it's increasing at a constant rate, which is a fair assumption. And then to get this line, what I did was I found the average speed, which was 2 meters per second. I put that average in the middle of the interval. And then I just drew a line that goes through that middle point. Okay, so that does it for section 1. Hopefully that wasn't too confusing. You may have to watch that a couple of times over for it to really sink in. So what about section 2? Notice how in section 2 this is a horizontal line, and what does that mean on a displacement versus time graph? That means that the object is not moving, right? Its displacement is not changing at this 6 meters, and this is happening for 2 seconds. So that means its speed is 0. If an object is not moving, its speed is 0. So from 2 to 4 seconds, the graph is going to look like this. Right? The speed is going to be 0 meters per second. Okay, what's happening now in section 3? Well, notice section 3 is going from the 4-second mark to the 7-second mark. So section 3 is happening for a total of 3 seconds, and notice that it's just a line that's sloping downward. Well, a line that is sloping downward, since it's a line, it means that the object is moving at a constant speed throughout the whole time. Now, at what constant speed is it going to be moving? Well, notice it goes from a displacement of 6 meters at the beginning to a displacement of 3 meters. So it covers 3 meters in 3 seconds, right? So it goes from 6 meters to 3 meters from 4 to 7 seconds, right? So 6 minus 3 is 3, and then 7 minus 4 is 3 as well. So 3 meters in 3 seconds, that is 1 meter per second. So that's the average speed, and that's the speed throughout, because this is a line. It's not like this shape here where the speed was constantly changing. Here, because this is a line, the speed is constant, and it's constant at 1 meter per second. So from 4 to 7 seconds, the speed is constant at 1 meter per second. And then finally, our last section, section 4. So what's happening from 7 to 8 seconds? Well, notice, as in section 2, we have another horizontal line on the displacement versus time graph. It means the object is at 3 meters the whole time for that whole interval, meaning it's not moving. Its displacement is not changing. When an object is not moving, that means its speed is 0. So from 7 to 8 seconds, its speed is 0. So that ends up being our final speed versus time graph for this corresponding displacement versus time graph. So pretty tricky question, especially this first section. So the first thing you want to do is you want to split up your displacement versus time graph into sections depending on the shapes that it takes. And notice that we had 4 unique shapes here. And then you're going to draw your speed versus time graph in those sections as well. That corresponds to the same time intervals. So section 1 was the toughest because the speed was changing. However, because the slopes of the tangents were increasing, we knew the speed was increasing. Now, we don't know whether this speed was perhaps maybe increasing at an increasing rate or increasing at a decreasing rate. Remember, there's those options as well. So you could have drew the the speed versus time graph for this section like that as well, but I feel like it's a good assumption to make that the speed is just increasing at a constant rate. Even though you can't tell, you're not going to get any marks off for assuming that, because you can't tell from a displacement versus time graph whether the speed is increasing constantly or at an increasing or decreasing rate. So always just put a constant rate. So the speed was increasing, and then these numbers we sort of got from the average rate of change. So we found that the displacement was from 10 to 6 meters. It traveled 4 meters in 2 seconds. So on average, its speed was 2 meters per second. So because the speed is constantly changing throughout the interval, I put that 2 meters per second in the middle of the interval at that 1 second mark. So if 2 meters per second was the middle, 0 was the beginning, that means 4 meters per second is going to be the end of the interval at that 2 second mark. So speed is increasing there, object is accelerating, and then the other sections were a lot easier. Section 2 and 4, the speed was 0 because the displacement was not changing. And then section 3, the object was moving but at a constant speed, and the speed was 1 meter per second. The slope of the line was 1, or -1 rather. But when you're looking at speed, you're looking at the positive value. So the speed was 1 meter per second throughout the whole interval, meaning that it's just a horizontal line on the speed versus time graph at that 1 meter per second mark. So yeah, anyway, kind of confusing. Hopefully you got that. Hopefully I explained it okay. Perhaps not the best explanation. You may have to rewatch that a couple of times. But yeah, make sure you're getting practice in taking a displacement versus time graph and then drawing its related speed versus time graph.